Hello dear friends, welcome to Gate Academy Global. So before starting today's session, I would like to take the feedback as well as concurrence regarding the quality of video as well as audio. If it is perfectly transmitted, let me know over the live chat just by telling perfect. Just by telling perfect. Is that part clear? Anyways, the agenda behind today's video and the series of the engineering mathematics which we have been running so far has been very precise and clear. We are learning the basic concept of the engineering mathematics from very scratch. What are the different topics we have covered? We have discussed about the logarithmic function, circular function, elliptical function, straight line. We also talked about the limit, existence of the limit, and we have taken few of the very well designed problems based on the concept of the limits. Yes, in the same sequence, in today's video, I have planned to take around 9 to 10 superbly or well planned number of problems. So what are they? You can see over the digital board. The first problem where the limit has been applied over a bivariable independent function. How many number of independent variables is getting involved within this function? Obviously the two number of independent variables are getting involved within this function. I have seen many of these students do not exactly know what does that actually mean of it, and many of the students even do not able to solve this sort of problem. That is why I have taken the two problems based on the limit where the function contains two number of independent variables. That has been the first question which has appeared in GATE Civil Engineering year of 2016. The problem was framed by ISC Bangalore. Once we are done with the first problem, we would move into the second problem. This had been a design problem, because just by watching or just by solving one problem, probably you may not be much comfortable with the two independent variable based concept of limits. That is why I have designed the next question, and once you are done with the first as well as second question, by default you would be able to solve any sort of the problem where the function contains the two number of independent variables, and whereas both of the independent variables must be moving to a certain point. सर मैं आपके लेक्चर यस ग्रेट डियर ओमकार रावल इज सेइंग सर मैं आपके लेक्चर रिकॉर्डेड देखता था क्योंकि मैकेनिकल का क्रैश कोर्स चल रहा था. टुडे इज फर्स्ट लाइव क्लास. दैट्स ग्रेट. नो, दैट्स ग्रेट. Similarly, in the same fashion, we are going to reach into the third problem of the day. This problem have appeared in GATE Electrical Engineering year of 2017. The problem was framed by IIT Roorkee, and this problem is based on the concept of the continuity as well as differentiability. If you have a fair idea about the continuity as well as differentiability, probably you would be able to smash this problem well. But still, once we'll solve this problem thoroughly, we'll try to draw this graph over the Desmos, and end of the day we will try to understand the graphical or the conceptual understanding of this problem. Yes, once we are done with this, we would move into the next question. Probably now you must be well acquainted how do we solve this sort of problem where we had the case of infinity minus of infinity. We have seen when I was discussing about the indeterminate form, infinity minus of infinity has been a form of indeterminate. So definitely we are going to learn how we would deal with this sort of problem. Once we are done with this, we would start taking the problem where I need to assess the existence of the continuity, limit as well as differentiability. At very beginning, I would deal with a very simplest form of the problem which had been mod of root of 3x plus of 1. Mod of root of 3x plus of 1. Once we are done with this, we would increase the complexity of this problem, and now we would move into the exponent has been raised to the minus of absolute of x. Obviously, it is difficult problem than the problem which we have appreciated. Yes. In the same sequence, we would move into the next problem, e to the power of minus x square. The student who have gone through the concept of probability distribution and density probably have gone through this function when we were discussing about the normal distribution, Gaussian distribution, or the Bell distribution, which used to be sort of this. But still we would take the reference of e to the power of minus x square, and we'll try to assess, we'll try to judge which type of function it had been. Whether it has been continuous throughout its range, it had been a differentiable throughout its range. Definitely we are going to discuss about this function also. Yes. Once we are done with this, we would move into the next question. See, this sort of problem has not been appeared in GATE examination. Probably 10 to 12 years back, once this problem had appeared in civil engineering, where we need to assess whether the function is continuous or differentiable within its complete range. But I have seen whenever the student used to have this sort of problem, they used to find little bit difficulty. That is why deliberately I tried to take this as two different problems where again the same agenda would be pursued, and there we had to discuss about the continuity as well as the differentiability of this function. Agreed? Once the 9th question is done, I would design one more problem which have again appeared in GATE examination, where I would be discussing about mod of x, and similarly where the x would be raised to 3. I would be discussing about its differentiability, whether its first differentiability is possible or not. If the first differentiability is possible, whether its second differentiability is possible or not. If it is second differentiability is possible, whether its third differentiability is possible or not. Yes, till this point probably each and everything must be clear to all of us. So without getting delayed, let me start with the first question, and obviously this first question have come in civil engineering year of 2016. The problem was framed by IC Bangalore. So let me bring this problem into the working room. So one more input I would like to have from each one of you. Would you like to have the screenshot of the solutions which I am providing over the digital board? If your comment is yes, just put yes over the live chat. So once the video is getting over, I would share the PDF of this screenshot or the screenshot of the screens which I would be dealing over here over my Telegram group. So probably you might be following my Telegram group, you will be getting the PDF over there itself. So let me bring this into the working board. Here goes the first problem. Read this problem carefully and try to get the best most answer within 1 minute. This problem should not take more than 1 minute. So your time starts now. Let me read the problem, what it says exactly. What is the value of limit x tends to 0, y tends to 0? You had a function which contains the two number of independent variables x and y, had been xy divided by of x square plus of y square. 4 different options were attached along with this problem. It had been a type of MCQ, that means only one answer would be a best most answer. The options had been, option A had been 1, option B had been -1, option C had been 0, the option D had been the limit does not exist. Tell me what would be the best most answer for this given problem. Himanshu Bharti, so I would do one thing. I would try to put the link of my Telegram group over the comment box itself. Probably I would not be able to put over the live chat because I am taking the class over here. So once the video is getting over the comment box, I would be giving the link of my Telegram group. Tell me what would be the best most answer for this given problem. So here goes my solution. Tell me what would be the best most answer for this given problem. This problem should not take more than 1 minute. So whenever I would display the question over the digital board now, probably I would give around 1 minute so that you guys would get more familiarization with the problem, and probably the student who have gone through the concepts would be able to solve that problem also. I would follow the same methodology over and over and over, again and again. So far no answer has been appeared over the live chat. Try to understand. So far the different kinds of the problems you have been solved based on the concepts of limit. Like you solve the problem like limit x tends to 0, sine of x divided by of x. Similarly, limit x tends to 0, 1 plus of x raised to 1 upon x. May I know what's the difference between the limit which we have been dealing so far and the problem which has been appeared first time? This was the limit where the function was univariate. How many number of independent variables were getting involved? Only one. But here the function has been bivariate. Could you understand what I am saying? Not many of the times, but once in a while this sort of problem has also been appeared in GATE examination, and you can expect in future you can encounter this sort of problems. So what I am saying over here, they all are univariate problems related to the limits. But as far as this problem is concerned, or in general you can say problem like limit x tends to a, y tends to b, of a function which contains two independent variable comes under bivariate limits. Bivariate limits. Bivariate limits. Bivariate limits. Could you understand? So the answer have started coming. Omkar Rawal says the answer would be A, which is not a correct answer. Could you understand what I am saying? So far the different kinds of the problem which we have dealt within the concept of the limit, they were containing only and only one independent variable, and that independent variable was forced to tends to a certain value. Maybe x tends to 0, x tends to 0, x tends to 1, x tends to infinity, x tends to 2, depending on the different problem. But the nature of the problem here as well as here is entirely different. Entirely different. In few of the books, even the limit x tends to a and y tends to b is also being written as x comma y tends to a comma b. That means the abscissa is going towards A, ordinate is going towards B, and again they would apply this limit over the bivariate independent variable, and that had been f of xy. F of xy. So this is just a different methodology to refer the same problem, because once we are done with this problem, the second problem which we are going to take in today's class, the methodology or the representation would fall under this category. Under this category. Tell me, my dear friends, what would be the best most answer? What would be the best most answer? I want from each one of you. See, what would be your methodology to solve this problem? So let me take a new slide. The problem had been limit x was tending towards 0, even y was tending towards 0. And as far as the bivariate function is being concerned, it had been xy divided by of x square plus of y square. My dear friends, if you guys would be able to recall, when we were dealing with the univariate function, how the existence of the limit was concluded. What I was doing, I was tending towards the test point. Let's take the test point has been A from the left hand side. So definitely I would restrict myself at A minus, and similarly from the right hand side, I would restrict myself at A plus. And if the worth of f of A minus is very same as f of A plus, what would happen? The limit would exist. There should not be any sudden change around A. That means the value of f of A minus as well as f of A plus must be very same. But here the concept is entirely different. This function is using the 2D plane, and the worth of this function, let's take, had been drawn over the z axis. So put together you can say the xy divided by x square plus of y square has to be drawn over the 3D space. For the time being, what I did, I took this digital board as a 2D plane where the horizontal axis has been taken as x and similarly vertical axis has been taken as y, and the z has been taken outside. Could you understand what I am saying? What's the difference between the problem which we have been dealing earlier and the problem which we are going to deal now? There I was using 2D plane where the magnitude was drawn over the y-axis, and similarly I was moving towards A from the left hand side as well as right hand side using the x-axis. So only two axes were getting involved, but here the three axes getting involved. X and y, they are independent variable, and the z, which would be the magnitude of it, would be the dependent variable over the x and y. Could you understand what I am saying? So let me do one thing. Let me take this becomes x-axis, this becomes y-axis, and obviously the z-axis is supposed to come out from the right hand thumb rule. Yes. See, may I know how you can reach to x is equals to 0 as well as y is equals to 0? In case of univariate function, you had only and only two different paths. Either you can come from the left hand side, either you can come from the right hand side, because you had got only and only one independent variable, and that has been x. So you can come to the test point taking the reference of x-axis alone from here. But here you can come from either of the side, because here the x as well as y are free to move independently. They had been the independent variable. Could you understand what I am saying? The x and y had been the independent variable. So without having the dependency over the x as well as y, the x and y can choose their own values. X and as well as y can choose their own values. Anyways, I need to reach to 0 comma 0. I need to reach to 0 comma 0. Can I use a path y is equals to of, let's take 2x plus 3? No, I can't. Why? Because when I would feed the x is equals to 0, the value of y would become 3. So that means you are not able to reach the origin of this function which had been 0 comma of 0. So obviously you would not be able to replace y is equals to of 2x plus 3. So rather using y is equals to of 2x plus 3, if I take another straight lines equation, let's take y is equals to of, let's take 2x. Y is equals to of 2x, where the slope had been 2, and definitely as y is equals to of 2x, the value of c has been 0, this straight line is going to cross through 0 comma of 0. Not only that, if you take the next kind of the straight line where the value of c has been forced to be 0, but the slope has been changed to 3. Similarly, in the same fashion, if I take y is equals to of mx, where the m is a real number, obviously if you feed the value of x, the y by default becomes 0. One thing had been quite sure, that y is equals to of mx would cross through 0 comma 0. Just try to understand in this way. Just try to understand in this way. How the y is equals to of 2x would be, obviously the slope would be positive, so it would be approaching, just a minute, it would be approaching 0 comma 0 in this fashion. Let's take, if you take y is equals to 3x, the slope would be even more, it would be approaching 0 comma 0 with a higher slope. Similarly, if you take y is equals to of minus 2x, it would be approaching towards 0 comma 0 with a negative slope. So as the value of m is changing, definitely the different path has been taken to approach 0 comma 0. But one thing must be sure, either you take this path, 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 either you take this path. How many different paths you can have? The infinitely different paths you can have. Lines should be passed from origin, obviously. You can take infinitely different path. They must be passing through the 0 comma 0, and if they are passing through the 0 comma 0, what I am going to do over here, rather reaching to the 0 comma 0, I would stop myself just before 0. What I am saying, I would stop myself just before 0, I would stop myself just before 0, just before 0, just before 0, just before 0, and I would cross check whether all of them are attaining the same magnitude or not. If all of them are attaining same magnitude, what does that mean of it? That means in vicinity of 0 comma 0, the magnitude of f of xy had been common, there had not been any abrupt change, and hence the limit of the function would exist. Could you understand what I am saying? So how many number of paths you can have? I have seen many of these students used to have doubts, sir, I need to check how many ways. So logically speaking, you can have the infinitely many number of paths. Not only that, even you can take y is equals to of x square, which used to be parabola. So even you could have taken another path, y is equals to of x square, that would also reach 0 comma of 0. You can take any of them. Could you understand what I am saying? Whenever you have limit related to the bivariate independent variable, the y has to be changed in a form of x. As the calculation has to be done over 0 comma 0, we'll see how the y can be connected with the x. If I take the reference of the straight line, y could have taken as m of x. So here the same process is going to be taken away. What we are going to do, y would be fed as mx, and as x is going to get 0, by default y is going to get 0. So let me feed this data over here. The x would remain x, the y would become m of x, divided by of x would remain x, and y would become m of x. And as earlier the x as well as y was moving towards 0, I just had to take the x has been moving towards 0. Could you understand what I am saying? Now what I am going to do over here, towards the numerator as well as denominator, the x square had been a common factor. X square over here, x square over here, x square over here. So definitely they are going to get out. Yes. So the component which would be left out over here is simply going to be limit x tends to 0, limit x tends to 0. Towards the numerator you would be having m, and similarly towards denominator you would be having 1 plus of m square. May I know what's the conclusion you could retrieve out of this? The conclusion had been, anyways, this complete function has been freed from x. That means in future the value of m is going to decide the magnitude. That means if you take m is equals to of 2, the worth would be 2 divided by of 1 plus 2 to the power of 2, that is nothing but the 5. Similarly, if you will take m is equals to of 3, the result had been 3 divided by of 1 plus 3 square, that had been 3 divided by of 10. That means the different straight lines are going to get the different magnitude in vicinity of 0, 0. Why I am saying in vicinity of 0, 0? Because still you are feeding x tends to 0 over y is equals to mx, and as the x has been fed to 0, definitely y is also reaching towards 0. Y is also reaching towards 0. Could you understand what I am saying? So one thing had been quite sure, what it is? The result what we are getting now, by feeding y is equals to of mx, the result had been, how much it is? M divided by of 1 plus of m square. And as it has been a function of m, that means the limit do not exist around x is equals to of 0, y is equals to of 0. If you want, you can write somewhere. As you can write somewhere, as the limit had been the function of m, and hence it would attain the different magnitudes. It would attain the different magnitudes. Could you understand what I am saying? Bilal Khan, very disgusting teaching. That's great, my dear friends. Probably you are ready to teach. So if you are ready to teach, definitely you should teach. So what I have been telling to all of us, most of the time we have been dealing with the problems where the limit do exist and the problems had only one number of independent variables. But here we had got a specialized case of the function where the two number of independent variables are getting involved. Whenever you have this sort of problem, what you had to do? You had to search a certain function, maybe a straight line, maybe a parabola, where you must be able to reach to the same point taking the help of that straight line as well as parabola. And end of the day, what you had to prove? End of the day, you had to prove that through the different path, you have been reaching to the same magnitude. If the result comes the same, definitely the limit would exist, otherwise the limit would not exist. Could you understand what I am saying? So may I know what should be the best most answer for this given problem? So the best most answer for this given problem is limit does not exist. Could you understand? So in the same sequence, let me move forward and bring the next question in front of you guys. And it has been the second question of the day. Let me take this screenshot. So here goes the second question of the day. If the question is not visible to you guys, let me orally communicate what it has been clearly written over here. Limit x comma y tends to 1 comma 1 and had got the two part of the function. Towards numerator we had 4x plus of 2y, towards denominator we have got x plus of y is equals to of filling the blanks. Now we have got the four different kinds of the options. You have to pick the best most option for this given problem. Tell me, how will you approach this problem? Again, the same concept has to be applied, but in first problem we have given plenty amount of time, but in second problem we won't give that amount of time and we'll try to solve this problem with the minimalistic approach. See what is happening over here. The same fundamental has been followed over here. As far as the limit which has been applied over a function had been a bivariate independent function. What are the different independent variables are getting involved within this function? That had been x comma y. Anyways, to solve this problem, what we do? We would take the different help of the different curves to reach 1 comma 1. May I know what are the different curves we can take for the help of? We can take either the help of y is equals to of x. When I would feed x is equals to 1, by default I would be reaching to y is equals to 1. So y is equals to of x is a straight line which would be passing through the 1 comma 1. So definitely I can take the help of y is equals to x. Now the second straight line, can I take the help of y is equals to of 2x? No, I can't take the help of y is equals to of 2x. Why? Because once I would feed x is equals to of 1, no, y would be 2. So definitely this straight line is not going to cross across 1 comma 1. So I cannot take the help of y is equals to of 2x. Similarly, in the same sequence, can I take the help of a parabolic equation y is equals to x square? Yes, I can take the reference of y is equals to of x square, because when I would feed x is equals to of 1, definitely even the y is also getting 1. Similarly, can I take the reference of y is equals to of 2x minus of 1? Obviously, you can take the reference of y is equals to of 2x minus of 1, because when you would feed x is equals to of 1, it becomes 2 into 1, that becomes 2 minus of 1, the y becomes 1. Again, y is equals to of 2x minus of 1 is being passing through 1 comma 1. So what you are going to do, you are going to feed y is equals to x, and then you are going to get the limit. You are going to feed y is equals to x square, and then you are going to get the limit. And similarly, now you are going to feed y is equals to of 2x minus of 1, and again you are going to get the limit. And if you are getting the same value of the limit in all of the three processes, lump sum, you can assume that there has not been abrupt change in the magnitude around x is equals to 1 comma y is equals to 1. Could you understand what I am saying? Could you understand what I am saying? Should I be repeating once again? If all of the path has been reaching to the same magnitude around x is equals to 1, y is equals to 1, for this bivariate function, one thing had been quite sure, the function do exist its limit around 1 comma 1, 1 comma 1. So that's the process we had to follow over here. So let me follow the first path. Y has to be fed as x. We had to reach at 1 comma 1. That means when the x would be fed 1, by default you would be reaching to y is equals to 1. So this process would become limit x tends to 1. Y has to be fed as x. So here it becomes 2 times of x divided by of x plus of, here goes x. End of the day, once you add them together towards the numerator, you are getting 6x. Towards denominator, you are getting 2x. X and x is getting cancels out. The what we are getting as an answer is simply going to be 3. Similarly, in the same sequence, what we are going to do over here, let me take the next path which had been the parabolic part, and we are reaching over 1 comma 1. So what we are going to do over here, instead the y, definitely x square would be fed in. So here it goes 4 of x plus of 2y, y would be replaced with x square. Towards denominator you would be having x, and similarly y would be replaced with x square again. And here the limit would be, you wanted to reach at 1 comma 1. So obviously as you will feed the value of x as 1, by default the x becomes 1 and y would also become 1. So here x has to be fed as 1. X has to be fed as 1. Let me get the value, how much we are getting. Again, as the x has been fed as 1, towards the numerator it becomes 1, the 4 and 2 gets added, it becomes 6, and towards denominator side the 1 gets added with the 1, it becomes 6 divided by of 2, we are getting the same result, and which has been 3. Similarly, in the same sequence, let me do the next calculation. You can feed y is equals to of 2x minus of 1, and again the same procedure can be followed. You would be feeding x is equals to 1, and by default while feeding x is equals to 1, y goes towards 1. If you want, we can check it out. So here it goes, limit x tends to 1, the 4 of x would remain as it is, 2 of y, the y would get replaced with the 2x minus of 1, and similarly the same process goes with the denominator, where the x would remain as it is, the y would get replaced with 2x minus of 1. You will get the same answer. So may I know what is going to be the best most answer? The C is going to be the best most answer. And you can expect this sort of problem near future, probably in GATE year of 2022 or maybe 2023. So just wanted to know, could you be able to solve any problem related to the bivariate limits? If yes, the answer is yes, just post the clear over the live chat, so I'll have the fair idea that you would be able to deal with this sort of problem in near future. So in the same sequence, let me move forward and let me go into the third question. I won't say it is a very tough problem, but you can say, yeah, it is a bit trickier problem, which has been the third problem of the day. The problem has appeared in GATE Electrical year of 2017. The problem was designed by IIT Roorkee. IIT Roorkee. This problem should not take more than 60 seconds to get solved. If this problem is not visible, let me read this problem completely. See, a function f of x is defined as f of x is equals to of e to the power of x for x lesser than 1, ln of x plus of ax square plus of bx, x greater than equals to of 1, where x belongs to the real sets. That means the x is always a real number. Which of the following statement is true? The four different options are attached along with this problem. It has been a type of MCQ. That means out of four possible options, only one option would be true. Fx is not differentiable at x is equals to 1 for any value of a and b. The second option goes like f of x is differentiable at x is equals to 1 for the unique value of a and b. F of x is differentiable at x is equals to 1 for all the values of a and b such that a plus b is equals to e. Here goes the D option, fx is differentiable at x is equals to 1 for all values of a and b. For all values of a and b. Tell me what would be the best most answer for this given problem. For this given problem. See, once you'll see this problem and once you'll see its option, one thing had been quite sure. The analysis of continuity as well as differentiability has to be performed around x is equals to 1. You can see everywhere. Fx is not differentiable. The blah 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 has been given, but that blah blah testing has to be done at x is equals to 1, at x is equals to 1, at x is equals to 1, and x is equals to 1. That's the first thing. That's the first thing. Secondly, as far as this function is concerned, the function had changed its nature at x is equals to of 1. Before x equals to 1, the nature of the function was pure exponent, which was e to the power of x. And after x is equals to 1, the nature of the function had been ln of x plus of ax square plus of bx. Yes. So let me write this function once again. F of x had been e to the power of x for x less than 1 and had been ln of x plus of ax square plus of bx for x greater than equals to 1. So with the help of this statement, we had to conclude about the continuity as well as differentiability of this function. Continuity as well as differentiability of this function. Anyways, the basic concept of the continuity as well as differentiability must be known to all of us. What does it mean by the continuity for continuous function? The function is said to be a continuous at a test point if the magnitude of the function just before the point, just after the point, and even over the point is very same. What about the differentiability of a function at a certain test point? There must be a unique tangent which can be drawn over the function, or the function must be continuous as well as smooth. There should not be any formation of the cusp. There should not be any formation of the cusp. So as far as the differentiability test is concerned, until and unless you are not making it sure that the function is continuous at x is equals to 1, it cannot be differentiable at all. So we had to make this function continuous. How this function would become continuous? This function would become continuous only and only the magnitude just before 1, just after 1, and the magnitude at 1 must be very same. Must be very same. So first we will start with the continuity. We will start with the continuity. The function would be found to be continuous at 1 if left hand limit is very same as a right hand limit and is very same as the worth of the function at test point, which had been x is equals to 1. Which had been x is equals to 1. Similarly, if you are interested finding the worth of the function at 1 minus, may I know which function has to be picked out? Obviously this function has been picked out because e to the power of x has been defined as a valid function when the x is lesser than 1, and obviously if I am saying the worth of the function at 1 minus, that means the 1 has been just shortened. Yes. So what I am going to do over here, it would be simply equals to of e to the power of 1 minus. What does that mean by the 1 minus? 1 minus is very same as 0.999999, or you can say it's the nearest value of 1 when you are approaching towards 1 from the left hand side. From the left hand side. Could you understand what I'm saying? Similarly, if you will take the reference of f of 1 plus, which function has to be carried out? Definitely ln of x plus of ax square plus of bx square has to be carried out. So once I will feed ln of x 1 plus, what does that mean by the 1 plus? Approximately 1 itself. Ln of 1 would become 0, it would become a into 1 square, that would be a itself plus of b. So end of the day, f of a plus is simply gonna be a plus b. A plus b, and here also the worth would be a plus b. Because at x is equals to 1, the worth has to be chosen with the help of second function. With the help of second function. Could you understand what I'm saying? So as far as the continuity test to be successful is concerned, a plus b has to be very same as e. In the same step, we are going to go forward and we'll be talking about the differentiability test. What does that mean by the differentiability test? The function is said to be differentiable at any test point, provided the function must be continuous at that test point and formation of cusp or corner. Or in totality, you can say the curve must be smooth and there I can draw a unique tangent. There I can draw a unique tangent. How will you know about it? You will calculate the left hand derivative. I can say dy by of dx at x is equals to of 1 minus, and similarly you would calculate the right hand derivative dy by of dx at x is equals to of 1 plus. There are several ways to calculate the left hand derivative as well as right hand derivative. The one method is a basic method which we have studied in class 11th, limit h tends to 0 f of c minus h divided by of f of c divided by of h. No, we are not going to do that much analysis, just focus over this. May I know at x is equals to 1 minus which function would be a valid function? Obviously e to the power of x. So what we are going to do over here, we are just going to take the differentiation of e to the power of x, and after the differentiation I would just be feeding 1 minus. In the same sequence, in the next sequence, series, what we are going to do over here, we are going to take the differentiation of this function, and end of the day I would be feeding x is equals to of 1 plus. May I know what would be the differentiation of ln of x? Ln of x would be 1 upon x plus of 2 of a of x plus of b, and end of the day the x has to be fed as 1. 1 plus 1 does not make any difference. So end of the day, the result what we are getting over here, it had been e to the power of plus 1, e to the power of 1, that had been e itself, and here it goes, x has been fed towards denominator side, it would be 1, and here it had been 2 of a plus of b. Anyways, the function to be continuous as well as differentiable, equation number 1 as well as equation number 2, both has to get satisfied. Could you understand what I am saying? You can't say, sir, LHD was equals to of RHD, but the function was not differentiable at x is equals to 1, then the function would be said to be differentiable at x is equals to no, not at all possible. First, the function has to be continuous at x is equals to 1, and even its left hand derivative as well as right hand derivative must be very same. That means you had to satisfy the equation 1 as well as equation 2. If you are not able to satisfy either of the equation, you can't say the function would be differentiable at x is equals to 1. Could you understand what I am saying? So once you will see, or once you will observe the equation number 1 keenly, you will get to know towards left hand side you had e, and similarly towards the equation number 2 you had e towards left hand side. So one thing I had been very sure, if equation number 1 as well as equation number 2 carries the same left hand side, definitely their right hand side has to be very same. So once we will compare their right hand side, the first equation had the right hand side as a plus b, the second equation had the right hand side as 2a plus of b. End of the day, what's happening over here? 2ab plus of 1, sorry. So here what's happening, the b and b is going to get out, and here the result what we are having over here had been 2a, a is equals to of minus 1. A is equals to of minus 1, and by keeping a is equals to of minus 1, you would be getting b is equals to of a certain fixed value. You would be getting a b as a certain fixed value. So may I know what would be the best most answer over here? What it says, fx is not differentiable at x is equals to 1 for any value of a and b. No. We have got a unique values of a and b for which the function would be differentiable. Secondly, f of x is differentiable at x is equals to 1 for unique values of a and b, obviously. and even the unique values can be easily calculated. F of x is differentiable at x is equals to 1 for all values of a and b where the a plus b had been e. My dear friends, a plus b has been made as e, no, the function would be continuous, but you cannot ensure its left hand derivative as well as right hand derivative would be very same. So I have seen many of the times the student go ahead this as the correct answer, which is not the correct answer at all. If they could have designed this problem, the values of a and b for which the function would remain continuous at x is equals to 1, definitely the requirement would have been a plus b is equals to of e. But you also want to be your function to be differentiable at x is equals to 1, you had to satisfy the equation 1 as well as equation 2, and that is not at all possible until and unless you are not getting a unique value of a and b. Similarly, f of x is differentiable at x is equals to 1 for all values of a and b. Not at all. Not at all. Could you understand? I can't say it was a difficult question, but yes, this question requires a good amount of patience as well as perseverance. Should I be repeating how the problem has been approached? They were talking about the differentiability as well as continuity test at x is equals to 1. So I forgot about the remaining test points. I was just focusing over the x is equals to 1. And the problem looks genuine because the nature of the function got changed at x is equals to 1. So there could be a possibly discontinuity or the non-differentiability at point x is equals to 1. So what I did, I wrote the f of x once again. At very beginning, I was making it sure that the function is continuous at x is equals to 1. For that, what I did, left hand limit, right hand limit, the worth of the function at x is equals to 1 has to be very same. I did the same. And that is possible only and only when the a plus b is precisely equals to of e. That means in future, if you are able to ensure that the a plus b is equals to of e, there is no doubt the function would be continuous at x is equals to 1. That is why they have framed this as an option C. But you also had to ensure that the function is differentiable at x is equals to 1. For that, what you had to ensure, the left hand derivative as well as right hand derivative has to be very same. Once you did it same, if you did it same, the value of a had been unique, and once you will feed the value of a either in equation 1 or the equation 2, you will be getting the unique value of b. So may I know what would be the best most answer? The best most answer would be option B. Would be option B. Would be option B. May I know what would be the value of b over here? What would be the value of b over here? So we had e to the power of x, ln of x plus of ax square. A had been minus of x square, and similarly plus of b of x. What would be the worth of b? You can feed this value of a which had been minus of 1, so b would be e plus 1 into of x. I would request to each one of you, already I have been using the Android application Desmos many of the times. You draw the two different curves over the same plane that had been e to the power of x, and the second one is ln of x minus of x square plus of e plus 1 into x. You will see both of the curve has been attaining the same magnitude at x is equals to 1, and even their tangent has been very same. Okay, then in the same sequence, let me move forward. So let me take the next question, which has been the question number 4. This sort of problem is already been practiced in the last video. So probably the student who have been continuing following my video would be able to solve this problem. This problem has appeared in GATE instrumentation year of 2016. The problem was framed by IISc Bangalore. Let me focus over the problem what it states. The limit n is being tending towards infinity, and the function had been root over of n square plus of n getting subtracted with root over of n square plus of 1 is. Here it was a fill in the blanks type of problem, and put together it was a NAT type of problem. That means you had to feed the answer with the help of clicks of your mouse. It's a type of NAT, numerical answer type. See what is happening over here. When you would solve this problem by just feeding n is equals to of infinity in the complete function, you yourself would be able to notice that it becomes infinity square plus of infinity minus of infinity square plus of 1. May I know what would be the worth of infinity square? A very large positive value. If it is getting multiplied with a very large positive value, result would be a very large positive value put together. Infinity square would be treated as infinity itself. Now very large value is getting added with a very large positive value. Again the result would be infinity. Root over of infinity would again result in infinity. And the same process goes over here. Infinity square would be infinity. Infinity, which is a very large positive value, is getting added with 1. There would not be any change. It would remain infinity. Put together, it had been a case of infinity minus of infinity. I know many of the students used to write infinity minus of infinity as 0. Many of the students may write this as infinity, but we have seen probably 4 to 5 days back, it had been a form of indeterminate. It had been a form of indeterminate case. So obviously neither the answer can be written as 0, neither the answer can be written as infinity. And even this problem could not be solved with the help of L'Hospital rule, because the L'Hospital rule deals with the indeterminate form. How many number of indeterminate form we have? The 7 indeterminate form we have, but out of 7 number of indeterminate form, it deals with only 2 specialized conditions, 0 by 0 as well as infinity by infinity. So what I would be doing? I would be using the method of rationalization. I would be using the method of rationalization. So here goes the limit where the n has been tending towards infinity. We had the function n square plus of n minus of n square plus of 1. While rationalization, what we do? We used to convert this problem in the form of a minus b into a plus b. Already it has been arranged in the form of a minus b, so definitely we want its counterpart, that had to be a plus b. That means root over of n square plus of n plus of root over of n square plus of 1 has to get multiplied towards numerator. So just to make it neutralize, you had to multiply towards denominator side also. So the factor which would get multiplied towards numerator as well as denominator would be, and yes, here goes the another multiplication which had been root over of n square plus of n, and here goes root over of n square plus of 1, n square plus of 1. So once we'll apply the simple algebraic identity a plus b into a minus b is equals to a square minus of b square, what would happen? Obviously this square root is going to get cancels out. The factor which will be left out towards the numerator side had been root n square plus of n. The minus would get indulged with n square plus of 1 completely, and towards denominator side you will be having the factor like n square plus of n plus of root over of n square plus of 1. Yes, and here now the limit n has to be tend towards infinity. The n has to be tends towards infinity. So in the same sequence, what is happening over here? The n square, the second degree component towards the numerator is getting cancelled out, because here it was 1, here it has been minus 1. So the factor which has been left out towards the numerator had been n minus of 1, and towards denominator it had been root over of n square plus of n plus of root over of n square plus of 1, and the same process has to be followed over here. The limit n has been tending towards infinity. N has been tending towards infinity. See what is happening over here. When we were discussing about the basic form of the limits where the limit x tends to infinity, we just focus over the degree of numerator as well as degree of denominator. If the degree of numerator as well as denominator had been in same degrees, the result would always be constant. May I know the highest degree which has been present over the numerator? That had been 1. Similarly, the highest degree which had been present towards denominator, although it had been n square, but once the n square would be brought out from the square root, definitely it would be in the degree of 1. It would be in the degree of 1. Yes, it would be in the degree of 1. So what would happen in the last? You can take n common from out of it. So the factor which will left out would be 1 minus of 1 by n. Here it would be 1 plus of n divided by n square. Put together, once you'll solve this problem, you would have the answer as 1 divided by of 2. So the best most answer what we are getting for this problem had been 0.5. That had been 0.5. Could you understand? So probably you could have smashed this problem. In the same sequence, let me focus over the next question. Let me focus over the next question, and this has been the fifth question. Tell me what would be the best most answer for this given problem. This problem has been based on the concept of continuity limit as well as differentiability. We have taken a modulus or absolute function of 3x plus of 1 is continuous and differentiable, continuous but not differentiable, not continuous but differentiable, not continuous and not differentiable. See, the test point has not been defined along with this problem. What does that mean of it? That means the complete real number or the complete range of x would be taken as test point. That means at any moment of time, if the function fails to give a continuity, by default it becomes discontinuous, and at any moment of time if the function fails to give the differentiability test, by default it becomes non-differentiable. Tell me what should be the best most answer for this given problem. The student who have been following my lecture since beginning, they must be knowing about the nature of the modulus function which has been applied over the linear polynomial. What we do? Mod of 3x plus 1, definitely it would be a upper facing V shape. Where the critical point would take place, how the critical point takes place, or how we calculate the critical point. What we do? The linear polynomial is get compared with 0. And once we compare 3x plus of 1, we get the result of x as minus 1 by 3. So minus 1 by 3 is a critical point at which the cusp of the V shape would be formed. So let me do one thing. Let me take the x-axis as well as y-axis. Here goes the x-axis and here goes the y-axis. The cusp would be formed at minus 1 by 3. It would be upper facing V shaped, which we have seen many of the times. Upper facing V shape it would be. Anyways, what would be the nature of the curve before minus 1 by 3? Obviously, it would be minus times of 3x plus of 1. That would be minus 3x minus of 1. May I know what would be the slope? The slope would be minus 3. As you can see, the value of m had been minus 3. And similarly, once you go beyond minus 1 by 3, the nature of the straight line would be very same as the plus times of 3x plus of 1, which would be 3x plus of 1. May I know what would be the slope over here? It would be plus of 3. It would be plus of 3. Yes, so at least one conclusion we could have retrieved out of this. What it is, the function had been continuous throughout the range of x, and the function has been forming a cusp at x is equals to minus 1 by 3. That means I can't say the function had been differentiable throughout the range of x. So may I know what would be the best most answer? Continuous and differentiable. It had been a continuous throughout the range of x. It had been a differentiable throughout the range of x, except x is equals to of minus 1 by 3. So obviously A cannot be the correct answer. Similarly, continuous but not differentiable, yes, it seems to be a correct option. Similarly, the C and D has been ruled out. C and D has been ruled out. Could you understand what I am saying? In the same sequence, let me move ahead and let me take the question number 6. Here goes the question number 6. Here goes the question number 6. Tell me what would be the best most answer for this given problem, because I don't see this sort of problem very frequently in GATE examination. We don't see this sort of problem in GATE examination very frequently. E to the power of minus of mod of x is continuous, differentiable, non-continuous, non-differentiable, so on and so forth. Anyways, this cannot be the option at any case. Why? Because if the function is not continuous, it can't be differentiable. Just for sake of making the 4 different options, what the people do? They would make the 4 different options, but out of 4 different options, the one option cannot be true at any case, where the function is non-continuous but found to be differentiable. No, it's not at all possible for any kind of function. So C has been ruled out. C has been ruled out. Tell me, out of A, B and D, which would be the best most answer? Which would be the best most answer? So let me bring this function. For the surgery, it had been e to the power of minus of mod of x. If the modular function has been removed, definitely the function would split in 2 parts, taking the reference of x is equals to 0, because the mod of x is being defined as a minus of x for all negative value of x and is being defined as a plus of x for all positive value of x. So end of the day, it could have been written as e to the power of minus x as well as plus x. It would be e to the power of plus x when the x is less than 0, e to the power of minus x when the x is greater than 0. And even you can take the equals to sign, because at x is equals to 0, when you will feed x is equals to 0 in the first equation as well as second equation, you will be getting the worth as 1. Worth as 1. Could you understand what I am saying? So one thing had been quite sure, e to the power of plus x would be continuous throughout the range of x when the x is less than 0. E to the power of minus x would be completely differentiable function, which we have seen it used to be exponentially decaying function, which used to be a very smoother function. So e to the power of minus x would be a completely continuous as well as smooth function for all possible values of x which has been positive. So only one problem you can expect, and that problem had been at x is equals to 0. So what we are going to do over here, you are going to get the left hand derivative as well as right hand derivative. Right hand derivative, how will you get the left hand derivative? You'll calculate the differentiation. You'll calculate the differentiation of e to the power of plus x and e to the power of minus x. Why towards LHD the differentiation of e to the power of plus x has been taken place, and why the differentiation of e to the power of minus x has been taken place for the RHD? Because the function has been defined as e to the power of plus x towards the negative value of x, or towards the left hand side of x is equals to 0, and it has been x greater than 0. X greater than 0. Could you understand what I am saying? So as far as this problem is concerned, once you will take its differentiation, the function has been found to be e to the power of x. Here it had been found to be e to the power of minus e to the power of x. Here the x has been fed to be 0. X has been fed to be 0. Here the result would be plus of 1, and here the result would be minus of 1. Plus 1 and minus 1, they are not matching. Plus 1 and minus 1, if they are not matching, one thing is quite sure. What it is? The function won't be differentiable at x is equals to 0. So may I know what would be the bestmost answer? No. It had been a continuous throughout the range of x, but it had not been differentiable throughout the range of x. It has found, or it has formed a cusp at x is equals to 0. Obviously, it won't be differentiable throughout the range. That's the first thing. Continuous but not differentiable. The B is gonna be the bestmost option. The D would be ruled out. D would be ruled out. If you really want to see how this curve would look like, so let me do one thing. Let me try to draw how the curve would look like. Just a minute. So let me show how the curve exactly would look like. So here goes 613079, and let's take just a minute. So just let me show that the e to the power of minus mod of x is not been formed as a differentiable at x is equals to 0. Just a minute. Share my screen. Yes. Here goes my screen. Yes. So what we are going to do over here, I am going to take the help of Desmos. Here goes my Desmos. Let me change this mode to the night mode. Yes, it has been changed to the night mode. And let me draw the curve E. Let me see where the E had been. Just a minute. Whether the E is visible to any of us? Let's see. E. Because yesterday it got updated. E to the power of minus x. Anyways, I am not exactly getting where the E is being there. You see where the E has been there somewhere? E. Because it was got updated yesterday. Let me come down. Let me go back. No, it has not been visible. It has not been visible. But anyways, once you'll draw this, know how the curve would look like. How the curve would look like. Let me go back. The curve would something like this. The curve would something like this. See. E to the power of minus of mod of x. The curve would look something like this, and you yourself would be able to understand the curve had been formed at x is equals to 0. Here the slope has been positive, almost 45 degree. That means plus of 1, and here it had been negative. Here it had been negative. Could you understand what I am saying? Could you understand what I am saying? So with the help of Desmos, you could have drawn this curve, and once you'll see the curve, you yourself would be able to understand one thing. At x is equals to 0, the cusp has been formed, and as the cusp has been formed at x is equals to 0, definitely the function would not be differentiable. In the same sequence, let me take the next question. Let me take the next question. Next question, just a minute. e to the power of minus x square, e to the power of minus x square, e to the power of minus x square. I want the answer from each one of you within next 2 to 3 minutes. The 7th as well as 8th. May I know what would be the best most answer for the question 7 as well as question number 8? What would be the best number? Joginder Garwal. Yeah, I think we are in process of getting that back, but still that was a completely hack. So the Dande sir or the corresponding team member would be able to tell about our main channel into great detail, but still here we are for the study of the mathematics, so better to focus over the mathematics itself. Tell me. So 7th, 8th as well as 9th. 3 questions would be the homework for all of you. Better to take the screenshot of the question number 7, question number 8 as well as question number 9. You had to put its answer over the comment box. I repeat, you had to put its answer over the comment box for the question number 7, question number 8 as well as question number 9. Definitely I would try to reply over the comment box itself. And these 3 questions are very well designed problems. So probably if you guys would not be able to solve this problem, I would take this 3 problem tomorrow in priority basis. Okay then, and from tomorrow onwards probably we would go into the next topic. No, not next topic. We are going to take few more critical problems based on the concept of the same concept, the continuity as well as differentiability. So we'll meet tomorrow precisely at 9 PM. Till then, bye bye, take care, good night.